want to give a little bit more explanation about the salts and why you end up with different pHs with different salts. So let's assume that all of these are soluble because, by the way, alkali metals are always soluble. Ammonium, always soluble. If you remember that solubility thing way back in Gen Chem 1. So bisoluble, we mean that when we put this into water, we have all Na pluses and all Cl minuses. And when this goes into water, it's all Na pluses and all ClO minuses. And when this goes into water, it's all NH4 pluses, oops, and all Cl minuses. All right, so then the big question is, does that ion combine with water and do something with it? So if we go in here and we do HOH, so this is positive, it's going to be attracted to this OH part. Notice there is no H or NH in these two to give up, so they're going to be attracted to the different ions. So the Na is going to be attracted to this OH group. So I'm going to get NaOH plus H plus. Hang on just a second, I'm going to go ahead and write out the Cl1 also. And the Cl is negative, it's going to be attracted to this positive part, and so I'm going to have HCl plus OH minus. So as it stands, I have an acidic solution and I have a basic solution. However, take a closer look at this NaOH. That's a strong base. HCl is a strong acid. What are the strong bases? Well, the alkali metals plus OH, that's going to be a strong base, and the lower half of the alkaline metals plus the OH. Those are your strong bases, and your strong acids are, and you probably want to have this written down somewhere, HCl, HBr, HI, HNO3, HClO4, not the same thing as HClO, and H2SO4. All right, so then when you put these all in here, you're going to be looking at what's going on with the salts. So yeah, it makes NaOH, but NaOH immediately, it completely dissociates in water. So what we really have is Na plus OH plus H plus. And what we really have here is Cl minus plus OH plus H plus. So then these recombine and you remake water, and you don't have any kind of acidity or basicity at all. That's why something that will make a strong base doesn't have any pH, because it won't stay together with the OH from the water. It won't stay that way in water. It immediately falls right back apart. So it may be temporarily attracted to it, but it doesn't stay together. And same for the Cl minus. So I just explained this part for the Na for this one. So that's what's going on here. Now let's look at the ClO. So ClO plus HOH, and again, it's not great form to say HOH, right? You're supposed to say H2O, but I do it so that you can see the negatives and the positives. So that's negative, that's positive. So ClO is negative, so it's going to be interested in that H. So HClO, again, not HClO4, not strong. Plus what's left over is OH minus. Now, in this case, this is a weak. This guy will not break apart in water. It mostly wants to stay together, and only a teeny tiny bit of it will break apart. That's why we have the ice chart, is for that teeny tiny bit that breaks apart. So only a teeny tiny bit of this is going to make H plus. We got to find the relationship between these two. That's what our Ka chart does. And we are going to need to use the ice chart. And this is a Kb expression. We're going to use the ice chart, and we're going to be able to solve for our OH concentration. And then if it wants to know the pH, then I'm going to have to convert it to pH. But it's enough in a lot of cases. I can just look and I'd be like, yeah, I've got OH, and it's a lot of it that I've got left over. Alrighty, so you know what happened in the final situation. You know what happened here for this Cl down here. So now let's look at the NH4 plus. So again, it's going to be attracted. Okay, wait a second. For the nitrogen compounds, they only deal in H's. They don't deal with OH groups like that. So they deal with H's. So this guy is going to give the water, and also they are bases, by the way, too. So they're going to give up that H. Sorry, I said that wrong. These guys, this is an acid. He's got extra H's. What he's aiming for is to try to be like this. If you have a nitrogen compound and it has a positive charge up here, it's going to want to give up that H and become neutral. So he's giving it to the water, H3O+, plus I'm left over with NH3. And so with this one, it's really easy to see that the NH3, like I've got extra H3O+, and I don't have anything else to do with it. And so this is going to give me something that's acidic. And again, I'm going to have to use an ice chart. Notice that this is a KB, I'm sorry, Ka, blah. And this is an ice chart kind of a situation where you have to do the ice chart to actually solve for it. So positive stuff is positive things will end up giving you a pH solution, and negative things, and that's if they don't like make something strong, of course, and negative things are going to give you a basic solution.